Almost 240,000 miles from Earth, our moon outshines every other celestial body in the night sky.
The moon, when it's up and when it's bright, makes us dream and wonder.
Our enigmatic neighbor is also the source of countless unsolved mysteries and age-old myths.
The moon is a spooky place. It's a mysterious place from the human perspective.
The moon is a beautiful and a really obvious thing to see. It's hard to miss, the big shining moon in the sky. So I think all people from all times have had some need to understand it, some need to relate to it.
Science may cast an empirical light on some things about the universe, but lunar experts are the first to admit they don't have all the answers when it comes to our moon.
Science is about process. We're never sure about explanations. We know so little about the moon because we've only been observing it close up for a few hundred years, and it's been there for over 4.5 billion years.
Our moon teemed with volcanic activity 3 to 4 billion years ago. Today, most believe it's an inactive, dead world floating through space. But is it? July 20th, 1969. Neil Armstrong took his historic small step during that first visit to the lunar surface.
It's one small step for man, one giant leap for mankind.
While on the moon, Armstrong reported seeing what he called an area that is considerably more illuminated than the surrounding area, and that the area seems to have a slight amount of fluorescence to it. What could it mean? Today, almost 40 years later, no one knows exactly what that light source was. But scientists have witnessed similar occurrences.
There have been a whole class of changes on the moon that have involved brightenings, color changes, and even gaseous emissions.
These events have left some, like NASA astronomer Bonnie Barati, perplexed by what they call lunar transient phenomena, or LTPs.
Lunar transient phenomena are controversial. Scientists are very skeptical about them. The problem is there's no observations, true and firm, on these events.
But ever since the Middle Ages, lunar observers have reported seeing these mysterious lights. They're usually witnessed in the dark, shadowy areas of the moon, where the contrast is greater.
They last anywhere from a few seconds to a few hours. And that's why they've been so hard to confirm.
Convinced that these ethereal displays are a real phenomenon, but unsure as to what's causing them, experts have honed in on several possible explanations.
There have been a number of theories that have surfaced for lunar transient phenomena.
Ever-changing views from Earth may be causing the appearance of bright flashes or surface changes on the moon.
Some of the events that I've seen are clearly just due to turbulence in the Earth's atmosphere. These cause movement and change on the moon.
But Barati thinks that not all LTPs can be explained by atmospheric turbulence. The anomalies that Neil Armstrong reported were seen from the lunar surface, so atmospheric turbulence couldn't be causing them. Many astronomers, like Laura Danley of the Griffith Observatory, believe that the high-velocity impact of meteors and asteroids accounts for much of this activity being observed from Earth.
They're traveling very fast, so when they smash into the moon, there's a big, bright explosion, really.
These impact explosions, known as fireballs, may be one source of the activity, but that premise has a gaping hole in it.
Even though we've seen these flashes on the dark side of the moon, we haven't identified a crater associated with any of them. And that's where we get into the controversy. There hasn't been any large event that has been unequivocally observed.
Another possible explanation is that when a meteor hits the moon and creates a massive crater, landslides around the crater rim kick up mountains of lunar dust. The fine dust could absorb and scatter light rays, or make it appear as if the moon has somehow changed its surface features.
It's possible that if a landslide occurred on the moon, you would see something from the Earth, the edge of a crater being obscured, a cloud-like feature forming. In other words, we would see a crater wall, an LTP, and then a collapsed crater wall. We've never seen that yet.
Perhaps the most controversial theory behind these lunar anomalies could alter our view of the moon entirely. It would challenge the belief that the moon has been geologically inactive for millennia.
One of the most intriguing explanations for lunar transient phenomena is active volcanoes on the moon. This is the most scientifically important because it would tell us that the moon is still geologically active.
Photographs taken during the Apollo space missions revealed a rocky formation on the lunar surface called the Ina structure. With this data, scientists speculated that the moon could have experienced volcanic activity in the last million years. The information was groundbreaking, and it meant that volcanic activity could be the primary source of LTPs, but most scientists are yet to be convinced.
The thing about science is whenever you have a theory or a model, you have to be able to get data of an event over and over again. In terms of these more mysterious brightenings or things that could be volcanic events, we've never actually had two independent observers obtain incontrovertible data at the same time.
Even if the moon isn't geologically active, some astronomers believe there may be gases left over from a time when the volcanic activity was prevalent. If residual gases reached the surface, the sun's rays would scatter colored hues of red and blue from the gas particles.
The moon could still be experiencing outgassing without having actual activity in the interior. There are minerals in the moon that produce gases, and they seep up to the surface of the moon and come out.
With so many lunar transient phenomena theories out there, which is the most plausible? Dr. Barati doesn't point to one explanation for the phenomenon.
I think the reasons for LTP are probably myriad. I think there's more than one explanation. It's not just one phenomenon, it's many different types of activities.
For now, the cause of the elusive lunar transient phenomena may remain hidden on the dark side of the moon. But the cause of full moon fever here on Earth may be even tougher to diagnose. What role, if any, does the full moon have on our bodies and our minds? When it comes to exploring the mysteries of the moon, perhaps the most celebrated and controversial is whether our satellite has any influence on the mind and body.
We know that there's some relationship between the Earth and the moon. And so it's perhaps not such a great leap to imagine that the different changes, the full moon, might have some influence on people.
There are lots and lots of mysteries, physical and psychological.
One of the words for madness, lunacy, comes from the Latin word for moon, luna. So I think throughout history, people have associated the moon with human psychology.
A lot of people really believe that the full moon affects their behavior, affects maybe their biochemistry or something like that.
There's a widely held belief among many people, including clinicians, that during the full moon, there are changes, palpable changes in emergency room visits, in pregnancy rates, in birth rates. There is a mythology about behavior, which changes consistently with the phases of the moon.
Anecdotal evidence abounds, but does science support the belief that a full moon has a measurable effect on the Earth's occupants?
People have long tried to associate the moon and the gravitational effects of the moon with behavior in people and animals.
Fact, the moon stirs up the oceans, which make up 70% of our planet. So if the human body is made up of 70% water, wouldn't that mean the moon has just as much pull on human beings? Some respected members of the medical community have reported changes in human behavior and physiology during full moons.
We must be open-minded and, as careful observers, continue to posit some relationship between changes in the lunar cycle and the way in which we behave, the way in which our health and disease patterns move ahead through time. Then we probably need to ask in creative and critical and rigorous fashion the question, is this possible?
There are some in law enforcement who believe that crime rates increase when the moon is full. But others manning the front lines aren't so sure.
The way I see it personally, I see it as a myth.
At the start of a full moon shift, Deputy Jose Castro with the West Hollywood Sheriff's Department scoffed at the idea that a lunar pull has any effect on people. But in his first 20 minutes on duty, 3 calls had already come in.
Right now we're responding to a 488, which is a theft that had just occurred. The call indicates that a male Hispanic, approximately 32 years of age, wearing an orange jail jumpsuit, no pants, wearing blue underwear, stole a book. Right now we're responding to a call of a 273.5, which is a domestic violence now that is happening. This is the first domestic violence we've had in a while, and it just so happens there is a full moon. Right now we're en route to a certain celebrity that lives within our area. The call states that a neighbor at this celebrity's residence is throwing bottles at the informant's front yard.
By the end of his busiest Tuesday night of the year, Deputy Castro's skepticism was beginning to wane.
I'll tell you what, at the beginning of the shift, I wasn't a big believer. But I'm becoming a believer now.
A lot of this is tied to the idea that the moon causes tides on Earth, so maybe it causes tides within people. But that just can't happen. The moon does not have a tidal effect on our bodies. My chest doesn't get bigger because the moon's pulling on it.
Dr. Peter Pressman, a medical doctor at Cedars-Sinai Hospital in Los Angeles, acknowledged that some of his peers believe that the moon influences human behavior.
Physicians who believe that the moon does affect our bodies and our behavior come to that conclusion on the basis of their observations. Now, those observations may be very skewed. They may be very situational, and they may not mean a thing, except that that's what somebody has observed.
But Pressman suspects the claims may contain a bias that's based on personal experiences.
If you look at the evidence, you find that there really is no clear mechanism for the influence of the moon with health and disease in human beings. Nevertheless, there continue to be astute clinicians and careful observers who insist that they do see relationships.
People's behavior is driven by what they believe, and if you believe there is something magical about the moon and it holds a spell over you, then perhaps you will change your behavior.
Whether the full moon has any measurable impact on body and mind will continue to be a source of debate and part of the mythology of our moon. And there are other mythological legends surrounding our closest neighbor. Even then, not everyone can see the man in the moon.
The man on the moon are these giant, dark areas that create what some people think looks like eyeballs and a nose and a smiley face.
Let me begin by saying that I have never seen the man on the moon. And how anyone can see it is a matter of subjective creativity.
The moon has long been the object of lore and myth, but what we think we see is all in the eye of the beholder.
Most cultures actually don't see a man on the moon. The rabbit is a big favorite among many, and there are others.
But everyone who looks up at the moon can see light and dark areas on the lunar surface. And these are not an illusion, but very real mountains and valleys. The light areas are rugged cratered highlands known as terrae, Latin for lands. The highlands are part of the moon's original crust that was shattered by the impact of meteoroids, asteroids, and comets. The darker areas on the moon are known as maria.
Mare is a word meaning sea. They are ancient lava beds that were at one time flowing but are now solid.
Formed from impact cratering over billions of years, the maria account for 16% of the moon's surface and look like bodies of water.
The latest thinking is that giant asteroids hit the other side of the moon and rocked the moon so significantly that lava oozed out of the side that we see and created these big dark expanses of lava that, of course, solidified over time.
The ancient volcanic activity that formed the contrasts of dark and light have inadvertently created what some see as the features of a human face. The eyeballs are actually the Mare Imbrium, Sea of Rains, and the Mare Serenitatis, which means Sea of Serenity. The nose is the Sinus Estum, which means Bay of Billows. And the open mouth is the Mare Nubium, the Sea of Clouds, and the Mare Cognitum, or Sea of Knowledge. For humans to see a man on the moon may be our way of trying to understand the lunar mystery and how we're inextricably connected to it. Many mysteries of the moon have influenced our civilization in dramatic ways. Ancient man based his calendar, agriculture, mathematics, and astronomy on the changing but consistent phases of the moon. Every month, the moon appears to change its shape during an 8-phase spin cycle. Why does the moon have phases?
The phases of the moon occur because as the moon orbits around the Earth, we see more or less of its lit side.
The light we see being reflected from the moon is actually coming from the sun.
Imagine the sun is over there, and this is the Earth, and this is the moon. When the moon is fully lit by the sun, and we can see that lit side, it's a full moon. As the moon goes around the Earth, we see less and less of the lit side and more of the dark side.
The full moon occurs when the moon is on the opposite side of the Earth from the sun, and the lunar surface facing us is fully lit.
The shapes of the phases of the moon are due to our perspective on Earth, seeing more or less of the lit side of the moon. It's not a case of, for example, the Earth blocking some of the light that would have otherwise struck the moon. That does occur, however, during an eclipse.
And that terrestrial perspective can sometimes play tricks on us. When it comes to the moon's size, looks can be deceiving. Some of the moon's mysteries are difficult to comprehend when our eyes tell us one thing and science another. We just need a different perspective on the problem. Sometimes when the full moon rises in the sky, it appears much larger near the horizon than it does when it's positioned higher in the sky. Some observers judge the moon to be as much as 50 to 75% larger when it first appears. But is the full moon really larger when it's near the horizon?
My friends all think that the moon is bigger when it's on the horizon. I think that the moon is bigger when it's on the horizon.
So what could be causing it to look so different?
The moon doesn't really change its apparent size from the horizon to overhead, but our perception is that it's larger.
One theory is that our mind judges the moon's size in relation to other objects.
It looks much larger at the horizon because there are things we can compare it to, whereas at the top of the sky, it's out there by its little old self.
In other words, if we see a large object, such as a house, dwarfed by the moon, our mind tells us that the moon must be enormous. But when the moon is out by itself, our mind doesn't make that assumption. We see the moon as small. Another possible cause of this is the Ponzo illusion, named after Mario Ponzo, who suggested that the mind judges the size of an object based on its background. Ponzo drew two identical bars across a picture of railroad tracks as they recede in the distance. The upper bars look wider because they appear to span the rails compared to the lower bars, which fits between the rails. But in fact, the lines overlaid on the tracks are the same size at both ends.
Go out and take a pencil, and when the moon's rising, put the pencil out at arm's length and see how big the moon is compared to the eraser on the pencil. And then go out a couple hours later and do the same thing when the moon is higher in the sky. And you'll see that the moon is exactly the same size in relation to the pencil eraser at both times.
The moon may play tricks with us when it comes to judging its size. But there's nothing imaginary about its effects on our Earth. Of all the hidden lunar mysteries, there's one that can be observed right here on Earth. It may be the most influential phenomena that can be attributed to the moon.
From our place on Earth, tides just appear to be the times of day when the sea rises and falls. But that's an interaction, a gravitational interaction between the moon and the Earth. So when the moon is passing by, it pulls on the oceans and pulls it up higher, and we see it as a high tide.
The ocean tides are caused by the gravitational pull of the sun and our moon.
The sun and the moon both pull on the Earth and contribute to tides, but the moon is much closer, so its pull of gravity is felt more strongly than the sun's.
Oceanographer Tatiana Ross says the moon's constant tug on the Earth is formidable.
The reason that the moon's influence is so visible in the form of tides is because water can run, it can move, it's malleable.
In a remote bay in Canada, one community has learned to live with mysterious and extreme ocean tides that are found nowhere else on Earth. While normal tides rise by an average of 3 feet, the waters along the Bay of Fundy between Nova Scotia and New Brunswick swell up to 50 feet twice every day.
One of the reasons the Bay of Fundy has such large tides is because of the shape of the landform underneath the bay. It's kind of a funnel shape, and so as the water level rises, it really rises rapidly.
At high tide, 100 billion tons of water sloshes into the bay in a matter of hours. Then during low tide, most of it drains out like a bathtub.
The bay is shaped just so that the first tide comes in like a wave and it moves along, it flecks off the back and it comes out to the mouth just at the same time as the next tide has built up. And so they add up in a thing called resonance.
Tidal resonance is just getting the rise of the high tides to coincide. Certain wavelengths are reflected in a way that they reinforce each other and amplify each other, and the tide is therefore amplified.
The unique funnel shape of the Bay of Fundy contributes to this resonance and the height of its tides. The bay gradually splits into a series of basins and river junctions that restricts the tidal flow and contributes to the extraordinary tides. Tides. One more way our planet is forever tied to the moon. But it doesn't end there. We know that the moon's gravity is constantly pulling up on the Earth's oceans, while the Earth's gravity pulls down on the moon.
Everything in space is tugging on everything else. So the Earth is tugging on the moon, and the moon is tugging on the Earth.
The moon's gravitational pull on our oceans is so powerful that it creates what's called a tidal bulge on both sides of the planet.
The moon pulls on the Earth gravitationally, and when it does so, it also pulls on the oceans that are sort of stretched up a little bit toward it. It pulls preferentially on the front side of the Earth, pulls the ocean toward it, then pulls the Earth a little bit less, and then the back side, the ocean is not pulled quite as far toward the moon. So that's why there are 2 bulges, they're called tidal bulges, on the Earth.
Tidal bulges on our vast oceans actually impact the Earth's rotation.
This tidal bulge is created by the moon. It's moving out ahead of the moon a little bit, and the moon is actually pulling back on this tidal bulge. Now, when the moon pulls back on this tidal bulge, that slows the Earth down.
Without our moon, the Earth would spin much faster and our days would be much shorter. And this would affect how life has evolved on this planet. But these tidal forces, which tie the Earth to the moon, travel a two-way street. Our Earth also has an undeniable effect on the moon. So if the moon had water on it, would the Earth's gravitational pull cause similar tides on lunar oceans? The answer is yes. In fact, billions of years ago, the moon was almost entirely made up of liquid, but not water.
When the moon was first formed and very young, it was entirely liquid rock, magma. The moon would have been like a blazing inferno in the sky. And because the rock was liquid, even though it was rock, the gravitational pull of the Earth and the orbit of the moon caused the liquid rock to have tides, just like the water on the Earth today.
Over time, the moon and its lava tides cooled into a solid, desolate landscape. But the gravitational relationship between the Earth and the moon has never ceased. But imagine if there was no moon making an appearance each night. How different a world would it be? We're always tied to this mysterious orb we call the moon. But what would have happened to Earth if there were no moon?
The fact that we exist today is in part due to the moon, allowing the Earth to create the environment, the early oceans, full of minerals that allow us to exist.
If there had never been a moon, Earth would be a different place today, because the moon creates tides on Earth that shape our shorelines and shape the landscape.
Here's how the moon impacted our evolution. About 4.5 billion years ago, the gravitational forces between the moon and Earth were much stronger.
When the moon was formed, it was much, much closer to us than it is today. It took only 5 hours for it to orbit the Earth, and it was huge in the sky because it was so much closer.
And more gravity exerted onto the Earth from a closer moon meant the world to our fate as a species. When oceans first washed our planet under a closer moon, the tides were 1,000 times greater than they are today.
You could imagine that instead of having a 10-foot tide like we have today, you'd have a 10,000-foot tide. So you would have 10,000-foot tides rushing inland.
These intense tides help create the right conditions in the oceans for life to develop.
Tides rip the outer layers of the crust off of the Earth and put them into the ocean. And that mineral-rich soup, the primordial soup, was capable of developing and evolving life.
And some scientists believe that tidal pools would have been an ideal setting for life to evolve and adapt to a terrestrial environment.
That would have been a great place, for example, for the first creatures from the sea to get their legs. They could have come into a tidal pool where it's wet half the day and dry half the day, and it would have been a great place to grow your legs and eventually move on to land.
According to astronomer Neil Cummins, we can't underestimate the moon's influence on our development as a species.
Without the moon, I don't think that that process would have occurred nearly as quickly. We have evolved so that our biological clocks are based on around 23, 24-hour time. If the moon had never existed, the day would be 6 hours long. And we, as the creatures we are today, couldn't exist.
As the moon slowed Earth's orbit, it stabilized our rotation and affected our climate and ocean tides. And the moon greatly influenced the development of mammals so dependent on moonlit nights for their survival.
Has the moon had a major impact on our existence? I think absolutely.
Every time the moon is full, the lunar image is exactly the same. There's a puzzling mystery to this. It makes many wonder why we never see another side of the moon.
After 4.5 billion years of evolving, the Earth-Moon system has arrived at a point where the moon shows us the same face all the time.
Billions of years ago, the friction created by volcanic tides caused the moon to slow its rotation and become tidally locked to Earth. This doesn't mean our moon isn't spinning, but it has slowed down considerably over billions of years. And the secret of the moon's hidden far side has to do with synchronicity.
If this is the Earth, and if this is the side of the moon that we see, if the moon were not rotating, then eventually we would see the other side of the moon. Because the moon is rotating at the same rate that it orbits the Earth, synchronous rotation, we always see the same side.
The far side of the moon is not always dark. If you were out in space, you would be able to see that the sun hits all sides of the moon as the moon makes its month-long orbit around the Earth. But from where we sit, we can only see one side.
Gravity is in firm control of the Earth-Moon relationship. Or is it? The gravity that has held the moon in our orbit is slowly losing its grip, and the consequences of that are enough to make one look at the moon in a whole new light.
Gravity is a force that holds the moon to the Earth. Just as this athlete is bound to the hammer that is orbiting about his body, so gravity binds the moon and the Earth. If gravity all of a sudden went away, the moon would fly off into space, just as this hammer flies off over the field.
Of course, gravity never stops working, but could the moon somehow slip loose of its grip? The truth is, the moon has always been slowly slipping away from us.
The moon has been moving away, and it's still moving away. In fact, the moon moves away from us a couple of inches every year, and eventually the moon's going to be so far away that it won't even seem like our moon anymore.
Ever since the moon and Earth became intertwined, the energy from the Earth's gravitational tug has been causing the moon to spiral away from our planet. It's currently moving away from us at a rate of 1 to 2 inches each year. The key to this unexpected effect are the tidal bulges created on the Earth by the moon.
The tides on Earth actually act to propel the moon outward, spiraling out further from the Earth every orbit. The reason is because the Earth spins faster than the moon orbits us. So after the moon has pulled up a tidal bulge, raised the high tide, the Earth turns and pulls slightly ahead of it. So there's just a little bit of a forward force, or we call it a torque, a little bit of an extra kick that speeds it up ever so slightly. But over time, that speeding up makes it go faster and faster, which in orbit means it's going spiraling further and further away.
Over time, the moon will expand its orbit until someday it will finally be beyond our Earth's gravity. But scientists say there's no cause for panic. Quite a bit of time will pass before the moon is out of sight and out of orbit. Estimated time of total departure, about 50 billion years. And our sun will flame out in less than 10 billion years. Throughout history, the moon has delighted, surprised, and sometimes terrified us. And the movement of our Earth may be the cause of this mystery. Another secret of the moon has been documented in ancient texts and continues to amaze. It usually appears every few years. During a total lunar eclipse, the full moon dramatically changes colors. What causes this?
A lunar eclipse is very simple. It just occurs when the Earth gets between the sun and the moon. So when Earth gets in the way, Earth casts a giant shadow that blocks the sunlight from reaching the moon.
At the peak of this eclipse, the moon passes completely into Earth's shadow, or umbra, and transforms not to black, as one might expect, but to a blood red.
What happens is, some of the sunlight that's being blocked by the Earth actually slips through the atmosphere, and the red light gets through the best.
As the sun's rays pass through the Earth's atmosphere, they're bent a little bit, and the red rays are bent in such a way that they make it over the surface of the Earth and illuminate the moon.
And when only red or orange light reaches the lunar surface, the moon appears red. another optical phenomenon that adds to the moon's mystique. And part of that mystique can be attributed to the dramatic presence of the moon above us. It outshines every other celestial body in the night sky.
There's a special magic to the moon. Its changing phases, its brightness in an otherwise dark sky.
But we also see the moon during the daytime. Why is this?
It's actually very easy to understand why we can see the moon during the daylight. You can do this demonstration at home. All you need is a bright light to act as the sun and a piece of fruit to act as the moon. My face is acting as the Earth. The lit up side is the daylight side, and the part in shadow is the nighttime side. Now the moon, of course, orbits the Earth, and at some of the times during the month in its orbit, it's on the daylight side of the moon. So I'm able to see it in full daylight.
Actually, many planets and stars are just above us during the daytime, but the light from the sun is just so bright that it obscures nearly all of them. Only the moon, which is 100,000 times brighter than the nearest star, shines through. We don't always see the moon during the day because it's constantly moving around our Earth, and it's not in the same position at the same time every day. But somewhere on the planet, it's always visible. But as we've learned, not everything about the moon is easy to explain or understand. There are still plenty of questions left unanswered. It's been part of the moon's mystique since history was first recorded. We are forever tied to our neighbor, but we know so little about that dependence.
There could be other things that are happening that we just don't know about yet.
Over the next century or so, I think that science is going to take us further into understanding its mysteries. Whether we will fully understand it, I doubt it.
I certainly don't think we know everything there is to know about the moon. There's a tremendous amount to learn. But fortunately, it's within reach, and we will go exploring it further and learn a lot more about it.
Until we rekindle our efforts to explore the lunar world more thoroughly. We may never know all the secrets or hope to solve the hidden mysteries of the moon.